Determine whether the integral is convergent or divergent, and evaluate if convergent. The integral from 3 to infinity, 1 over x minus 2 to the 3 halves dx. This is an improper integral. You can quickly see that because you have an infinity as one of the limits of integration. And so we have to use the definition of the improper integral this way. So we can rewrite this is the limit as b goes to infinity, the integral from 3 to b, and let's go ahead and rewrite the integrand as well. It's x minus 2 to the negative 3 halves dx. So now we first evaluate this integral as we would with the fundamental theorem of calculus, and then once we're done with that, we can take the limit to see if the improper integral converges or diverges. So we would have to find an antiderivative of this integral. So we could come over to the side, we could say let u be equal to x minus 2, du would then just be equal to dx. So our integral would turn into the integral with new limits of integration, whatever those may be, u to the negative 3 halves divided by, pardon me, u to the negative 3 halves du. And when we find an antiderivative of that, we add 1 to the power, so u to the negative 1 half, and then divide by that same number. And then, of course, we're going to evaluate that on our limits of integration. Multiplying by the reciprocal, we have negative 2 u to the negative 1 half. Well, let's go ahead and put in what u is. We'll back substitute. So u is equal to x minus 2 to the negative 1 half. And now we're evaluating this from 3 to b. So this is what we have for our integral at this point. Let's go ahead and put this over here. Negative 2 x minus 2 to the negative 1 half from 3 to b. Okay, now remember, for definite integration, you plug in the top number, substitute in the top number. So this is the limit as b goes to infinity. We're not going to try to do our limit until we get the evaluation part done. So negative 2 divided by b minus 2, and the 1 half power, notice the negative is what drops the b minus 2 into the denominator. The 1 half power changes into the square root, minus, then we substitute in the 3. So negative 2 divided by 3 minus 2 square root. So we have the limit as b goes to infinity. Negative 2 divided by the square root of b minus 2 minus, well, the two negatives are going to make a positive. 3 minus 2 is 1. Square root of 1 is 1. So this is plus 2 here at the end. Now when we try to take that limit, of course we can take the limit of each term separately. So the limit of 2 is just 2. But notice that in this term, b is going to infinity, so it's getting larger and larger and larger. When you subtract 2, that doesn't do much for it. When you take the square root, you're still getting larger. Notice if you look at the graph of the square root, as x gets larger, the square root also gets larger. So you've got negative 2 divided by a very large number. That's a very small number. And as the denominator grows larger and larger, that's going to get closer to 0. So in the end, our limit ends up being 2. This means that the limit converges. So in particular, the integral from 3 to infinity of 1 over x minus 2 to the 3 halves I said 2 and I wrote 3. Let's fix that. X minus 2 to the 3 halves dx converges because the limit converges, and is equal to 2.